Hello, algebra class. How you guys doing? I'm here with our last quiz video of the year, which is crazy, right? And you'll notice that I do have our notes from 13.8. That's because for these first three questions where it asks for, the vertical and horizontal asymptotes and whatnot, that's based on these variations that we have down here. What's nice is it's all based on this same function, f of x equals 3 over x minus 4 plus 2. And so let's get started. So the horizontal asymptote, again, that is, that's going to be the line that comes here that these guys never really touch, right? They get really, really close to, but never really touch. Well, that's going to be at a certain value y. Now, what adjusts the certain value y? Well, like in this first example, it's this guy. So this is going to be, again, the horizontal asymptote. So in this case, our horizontal asymptote is y equals 3. Right? That's going to be the line will never, ever reach a y value of 3. That's our horizontal asymptote, right? This is our b, right? Y equals mx plus b, or y equals x minus h to some power n plus k, right? So that's this guy here. So in this function, which value affects our verticals? Well, that's going to be this guy. So you'd say y equals 2. Now for the vertical asymptote, let's look at this guy here. Now remember, whenever it's the x, whenever it's adjusting the x value, right? You got to switch the sign, right? That's why here we're moving right twice. Right? You got to switch the sign. So here, again, it's going to be x equals a certain value. Well, we're subtracting 4, so it's going to be that value positive. So x equals that positive value 4. In this case, again, it's that positive value 2. I know it's weird that the horizontal asymptote deals with the vertical adjustment and the vertical asymptote equals the horizontal adjustment, but that's just the way it is, and it's because our x and y values, right? Although this is a vertical line, I'm measuring horizontally, right? Or this is a horizontal line, but it's measuring, it's telling me whatever the whatever grade or whatever value I'm at vertically. So it's a little bit outside the box thinking. Now, where these, the center, f of x, that's going to be at the value x comma y 4 comma 2. Okay. We didn't really talk about it in that note, so I'll just give that to you. Okay, now when graphing, what I've done here is I've actually given you guys a few x values, and I think these will just be important. Now what we can do is we could just come and plot our asymptotes right away. So I know at y equals 2, so 1, 2, right? This is my horizontal asymptote, although it's measured on our vertical axis. This is our horizontal asymptote. And our vertical asymptote is at 1, 2, 3, 4. Right? So the graph will not intersect with these values. Now, I've given us a couple, really only one value that's off the grid. But I think if you plot these points, you'll see what this bad boy is going to look like. I do recommend using these ones. I think they'll just be easier to plug into the function and solve. And you guys know how to do that. If you have questions, of course, you can ask me, but let's move on. Numbers 5 and 6 are actually based on 13.7, so they are kind of difficult. So this first one, on a farm, you use a combine. It's just a piece of farming equipment, and it harvests wheat field in 8 days. But the new combine, so the old one is 8 days, and the new one is 5 days. But what if we used both of them together? That's their question. Okay, so I'm going to help you set up this table, and then I'll tell you guys what to solve for. So we've got our old, our new, and both. So the old, right? Now we're not dealing with distances, but we are dealing with time and rate. Now the old one took 8 days, and the new one takes 5 days. Do we know how long it'll take both of them together? We don't know. It's not going to be, the old minus the new, because we're using them both at the same time. Well, both at the same time, what do we do for a number? We don't know exactly what it is, but we know it exists. A variable. Why don't we just call that bad boy x? Now for the rate is going to be fields, like fields harvested per day. Now we know we have one field, so one field per 8 days. In this case, it's one field per 5 days. But with both of them together, it's one field per x days. Right, that's a fraction. I just had to put it off to the side. So if we use, right, now we need to solve for x, okay, but we need a formula, and that's always the tricky part, besides setting this up, which is also the tricky part, hence the reason I'm doing it. If we make all of these into an addition problem, so it's the old plus the new will equal the rate of both of them together. This might look a little bit more familiar. Now what you need to do is multiply the least common multiple to each of these. Now our least common multiple is going to be our numbers, which is 8 times 5. 8 times 5 times x, which is 40x. Multiply 40x here, 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 and solve for x. You can leave it in fraction form. I'm excited to see what this is going to look like for you guys. Okay, moving on to number 6. I do recommend you doing this. There will be some of these on your test, and so you're just going to need to know the process. So, okay, Jack wants to measure the distance between his scout camp and another. So this is what we're going to figure out, distance, right? We know distance equals rate times time. Right? Okay. Okay. He can paddle his kayak at a rate of 5 miles an hour in still water. So that's the control. the rate of the river is 3 miles an hour. Takes Jack 10 hours to paddle to camp and back. So from the starting point there and back, 10 hours. 10 hours. And question mark, let's say miles, because we're talking miles. How far is the camp? Okay. Well, we know it's upstream because it's talking about a river versus downstream. And let's see. And rate, time, distance. So his rate going upstream is probably going to be harder than going downstream. So it's going to be 5 plus or 5 minus the river. 5 minus 3 equals 2. Whereas downstream, it's going to be 5 plus the river, right? Because it's going to be a little bit easier going downstream. 5 plus 3. So 8 miles an hour going downstream, 2 miles an hour going upstream. Now, we don't know what the distance is, but we know that time equals distance divided by our rate, or in this case, time equals distance, which we don't know, divided by 2. And in this case, it's going to be distance divided by 8. Okay, and this is going to be, because the total time, so this is going to be how we solve for it, because we know that distance over 2 plus distance over 8, right? His time upstream and his time downstream equals 10 hours. Okay. You can add these together and solve for D. Okay. I hope this video helps. If you guys have questions, we'll be able to go over it in class on Wednesday. Of course, you're welcome to email me. Otherwise, know that I love you. Bye.